Hi all, today I would like to discuss about voltage, current and power. I would like to make it as a series because it's a lengthy topic. So the first of all, I would like to teach this topic, the reason behind it. I would like to teach everybody how much power they consume in households and how to calculate it and how to understand it better and how can you control it at home. So that is where this series came into picture. So today we are learning about voltage, current and power and how these three related, and I would like to ask you a few questions to keep in mind active as long as this series is on. So the first question is what is voltage, the second one is what is current and what is power. So in terms of electrical networks or in terms of electricals, so we will deep dive into all these details and we understand better, and based on it we calculate everything in our daily life. So that's what this series about. Okay, so let's jump into the topic. I would like to explain about current now. In simple terms, I equal to represented with dq by dt, meaning what it means exactly. The change in transfer, the change in charge with respect to a time. It indicates the current. So even I would like to explain more about this. Usually, current we can define as transfer of charge or charge in motion. That means indirectly we may also transfer the energy. Why? The charge is transferring from one place to another place. That means indirectly energy is transferring. The golden rule here you should remember, we are not creating any charge and we are not destroying any charge. That means charge conservation holds. So to keep that in mind, we are not creating any charge. That is very important. Why? Yes, we will understand better while I just give you one example so that we can understand better. So let's assume we have a circuit with some simple light. Let's say you have a light here and you want to power this up. This is plus and negative. So I would like to add some switch here so that you feel more about this. Let's say this switch connected and the charge in motion started, and you will see surprisingly the light will power on here. Yes, how this is possible? You're indirectly forcing the charge to transfer from positive to negative by connecting the loop. That is how this KCL holds. I will get into these details later, but as time being, keep it this way. So when charge is started from one place to another place, this is the place where the energy is converted. Electrical energy is converted into light energy. So this is where our entire system works, meaning system means here electrical system. So we used to convert that electrical energy into different forms and we get benefited. So how much energy you consumed, based on that it will be charged. Okay, so yeah, in terms of current, I would say this way. Let's say you assume this is one wire having cross section A, and let's say some charge is moving in this direction. So indirectly we will say this is a q by t, meaning the total charge transferring with respect to a second, and this is the cross section where it is considered. So this is the one way of representing it. In terms of derivative, we will represent with dq by dt, the change in charge with respect to a time. Both hold same. Yeah. Now this is just to understand the current only. Okay. Let's solve some simple problem so that you will understand better. Let's say assume, let's say 800 coulombs of charge passed, maybe let's say utilized by one flashlight. Let's say assume this way. One flashlight utilized 800 coulombs of charge in 30 minutes. So how will you calculate the current? So I equal to, as usual we have a formula, I equal to q by t. So first convert this minutes into a second because we are interested in seconds. So 30 into 60 seconds per minute. So this would be 800 seconds, right? So yeah, our charge is 800 coulombs. So let's say 800 C by 1800 seconds. So let's say cancel 8 by 18. So just rearranging the numbers for better calculation. Let's say 800, right? So keep it 900 coulombs. So that will be more easy to calculate, right? So yeah, so let's say 800 coulomb charge, 800 coulomb charge. Now this is 1 by 2, that means zero point 0.5 ampere. This is the current it consumed so far. So if you understand this much charge utilized by this flashlight, maybe you can see, let's say you took a photos, let's say continuously. So your battery will drain, or maybe the capacitor which is connected to the flashlight will be dry. So it has to supply the charge. That is what we calculated as a 900 coulombs. That means indirectly you consumed so far 0.5 mil, sorry, 0.5 amps current. So this is how we calculate. Okay, so this is all about current. We will discuss about voltage and power maybe next, and maybe some few more examples to connecting each topic. Thank you all. And please subscribe and share if you like this concept, and if you feel that it's useful to anyone, please share it. Thank you all.